Hi, I'm Paul Bovingdon from Pickering Interfaces here at the Battery Show in Stuttgart. Today we're showcasing our BMS test demo system. This showcases various products from Pickering Interfaces, for example our battery simulators, programmable resistors for temperature emulation, fault insertion for broken wires, example, that kind of thing. This is really important for test because you need to know exactly how your BMS is actually going to behave in a real world situation. You can simulate all you like in software, but it's not until you hook up real world stimulus that you really find out how it's going to behave. So in this system, we can provide power just like a battery would. We can also sync current as if it's being charged from a real world charger. It's connected up to the BMS, so as far as the BMS is concerned, it is connected to batteries, it is connected to temperature sensors, and you can test to see how it actually behaves. So if you go over temperature, for example, is it going to report that? Exactly the same with under temperature. Also, if you have unbalanced cells, again, the BMS will react accordingly. In this case, it will try to balance the cells. With a broken connection, again, how does that behave? Because obviously this is going to be generally in an electric vehicle, you want it to behave in an expected way rather than just failing and something catastrophic happening. Here we're simulating the charging of a battery cell. So we have a power supply in here which is providing power through the BMS into our cells. Then we have discharging. So in this case, we've switched out the power supply and now we have a load in there. So now through the BMS controlling the system, we're taking power from the cell simulators into our load module. We can also simulate over voltage. So here the cells have been raised to nearly 4 volts and you can see the BMS is actually responding by saying it's over voltage. And again, with an unbalanced cell, so here you can see cell 4 is lower voltage than the other cells. So in this situation, the BMS will be trying to discharge the higher voltage cells in order to balance them, because you do not want unbalanced cells in your system. Additionally, we have temperature emulation in there in the form of a programmable resistor module. So if we bring this down to a low temperature, it will report under temperature. So with the temperature emulation using a programmable resistor, if you increase the temperature, you can see here the BMS is actually returning an over temperature condition. All the details in the middle box here, labeled BMS UUT, is direct communication with the BMS itself. So you can see exactly how the BMS is going to react to a given situation. So yeah, that's the idea of the BMS test in order to test all those scenarios.